All right, we need to wait for a while until all of us have come back. Hello, can I have your camera on? Okay, let me know you're here, and let me know you're still in a good shape. Wong, I just saw Wong Nhật Long. Are you feel better? Okay, all of you, could you please go on the camera? Yes, thank you. Phùng Cá Hiếu, you feel better?
Feel better than before.
Okay. Wong Nhật Long, I just saw Wong Nhật Long. Wong Nhật Long, are you here, right? Wong Nhật Long. Not here? Now, for the time being, we are going to have we still have a lesson continue because we still haven't received any detailed arrangements from the EDB so far. No need to mention how the school will deal with it. So we can do nothing but continue, right, until the summer holiday comes. We don't know. And we need to read the memo word by word, such that we will know what can be done next. And our original plan, Mr. Wong and I, original plan is that we would have a starting from today, we start to have the coverage of organic chemistry together with some form assignment, okay? Which means that both Chem 1 and Chem 2 need to do this to be counted, right, in your continuous assessment marks. And similarly, we will have some work on form assessment, just like what we're having a quiz, okay? But it is in a uniform one. So in order to keep track of your understanding, I just heard from Mr. Wong that every Chem 1, Chem 2 lesson ends, the students there need to submit some homework, okay, right away. The classwork should be submitted right away. So I do think that is a very good practice to let me know that you are still here. You agree? Quite nice. Yes, if it is a good practice, why not? We try to follow. Okay, we try to follow that practice as well. So this is what I would like to draw attention to. Any questions? Okay. I forgot something. It doesn't matter. I go back to the iPad first.
Yes, that's right. So we come to this. Now, last time we stopped at talking about the baking of soap. Okay, what are the ingredients that where you make that you need to make the soap? Soap. What are the raw materials? Cyrus. Soap. Okay. Last time we stopped here. I asked you guys to find out those. Okay. Jiang Haming, are you here?
Yes, yes.
Yeah. Tell me, what are the materials of making anyway?
The materials.
Yeah.
Yes.
Can I have a more response from all of you? Oh, sorry. Okay, sorry. It's a must of all of you to open a camera in all lesson. Sorry, in all chemistry lesson. I need your cooperation. I hate that kind of waiting, and you just every time you just answer me yes. Okay, you just give me the hidden message. Huh? I didn't withstand that type of response. All of you, could you please open the camera? Otherwise, I cannot count your presence. Sorry. I can't wait, okay? Because if every time when I ask the question about 2 or 3 times but no response, I can do nothing but mark it as absent. To Form 4, Chem 1 and Chem 2 students, all 2 classes have turned on the camera in my class. I'm sure Form 5 students can do the same. Thank you. Answer, please.
The raw materials to make soapless detergents should come from petroleum and like benzene, concentrated sulfuric acid, and sodium hydroxide.
Now, I asked for the soaps. What are the raw materials for making soaps, but not soapless detergent? So it's different. The 2 terms gives you a difference. Soaps only. What are the raw materials of making soaps?
A triglyceride and sodium hydroxide.
Yes, we have that too. Okay, so in Western countries, they usually give a common name called lye. So it is just a strong alkali. Either it's NaOH or KOH. Triglycerides comes from fats and oil. Okay, so this is what you may know about that. Okay, for some other students, could you please open the camera? I just said it once again. Wang Senghi. 黃成軒。
我而家整緊嘅。
Thank you. So, and that's why we come to the concepts of this, right? You need to find out the comparison between soaps and soapless detergent. Okay. Now, we come to this. You see it? So we are going to have a table of content. You talk about soaps and soapy detergent, or we call it soapy detergent, and soapless detergent. Okay, by comparing the following. One, the raw materials of making the detergent. Okay, so anyone who know? You know the difference about that?
The raw material of making soap is some.
Yeah. Is what?
From 嗰個即係好似some oils or fats.
Some oils or fats, yes. How about?
And followed by the sodium hydroxide.
Okay, fats are oil. It is from animal or plants, where you have got that, and you are going to have sodium hydroxide. So indeed, potassium hydroxide is also okay, right, to make that soap. But usually we use sodium hydroxide. How about soapless detergent? Where you will find the soapless detergent? According to what you got from the book, okay, what you will get is from petroleum fractions, right? So you need a quite long synthetic route, okay, but all those, they are just simplified as making a ionic head by carefully design the long hydrocarbon chain. So what, no matter what is the source, the common point is that we would have a substance having a long hydrocarbon chain. Okay, by doing so, you will have a hydrophobic part. Okay, so the hydrophilic part we have it, and also we have got hydrophobic parts. And so this is what you get to know about this. What else? What is the difference between the two? So talk something more about the structure of it. The structure. This is from the petroleum fractions. All of you please mark it down. It's the petroleum fractions. So as long as the carbon chain is quite long, it serves a purpose. But it is not just the end. You need to add something more in order to make the structure. So take a look on the structure first before you need to add something. The basic structure of the detergent particle now should be this, okay, with the COO minus. How about the soapless detergent? It should be something like this, okay, with OSO3 minus. Okay, of course, depending on the alkaline to be used, we will have different cation, sodium ion or potassium ion, it can be, or you would have a very long chain, okay, with the benzene here, with the SO3 minus. Of course, the cation mainly is Na plus, Okay, but it can be K plus. So we would call that a sulfonate, benzene sulfonate or sulfate group. Okay, so this one is a sulfate. And this one, we call that benzene sulfonate. Okay, a type of benzene sulfonate. So what are they in common? Is that we have got this part, this being hydrophilic. Okay, hydrophilic. While we have got this part, and these hydrophobic. But usually it is in terms of a very long carbon chain. Now, in order to make it hydrophobic, I need a very long carbon chain. Okay, because of this, we need to add one. Because we have got sulfate ion containing, so we need to add something more on that. We are going to add corn salt to make the benzene, the sulfate there. Okay, corn salt. Corn salt. But making corn salt will not produce a salt. So later on, you need to acidify it and neutralize it to make it as a salt, and then NaOH. Now, before you get this, so this is our comparison about the structure of different detergent particles. Okay, is that clear? So you may refer to the book page 201. So what else? What are the differences between the two? What else can be compared? No, just this. So both, they are said to be a detergents is because the long hydrocarbon serve as a hydrophobic chain because it is oil soluble, while the hydrophilic head is water soluble. By doing so, it will process a emulsifying property and also wetting property. What else? What else can be compared? Anyone who can tell? Its working ability into different types of water. Would all that two chemicals can work well in all different types of water? So you talk about the working conditions of a soapy detergents and soapless detergents. For soaps or soapy detergents, they cannot work well in acid. Acidic medium. This one cannot. Why? It's because of the formation of RCOOH. Okay, it is a type of carboxylic acid because it is having a very long carbon chain. Okay, it's just a solid. So the cleansing property of the soap will be much decrease. Okay, while it works well in the acidic medium. Okay, no such. Okay, how about the second case in hot water? What is mean by hot water? Do you still remember? Do you still remember what is mean by hot water? What is containing inside?
我唔記得邊個，我唔記得。
記得 you better check it onto the web now. Hot water. Of course, the other term to compare is soft water. Please search it now.
Hard water 就係有high mineral content。
High mineral content of what type of mineral you are talking about?
Says carbonates of some magnesium or calcium.
Calcium ion and magnesium ion. Okay, so the solution containing considerable amount of calcium or magnesium ion. So why would you choose that too? Is because of the naturally occurring, okay, hot water is from spring water, underground water, while the underground water can be found in sinkholes, right? It's commonly found in sinkholes. While the sinkholes will have the rocks, okay, commonly called as calcite, limestone, etc. So it is calcium carbonate containing. Okay, while it dissolves in rainwater, finally it will have some water-soluble solution. So usually, if you want to talk about rainwater or underground water, is full of those chemicals, calcium ions and magnesium ion, and so that is problematic. While if you are going to react with magnesium ion or calcium ion respectively, what will be formed? So we will get something insoluble. So we will call that type of insoluble substance scum. Okay, so 浮渣. So it is somewhat insoluble substances, and once I have got that insoluble substances, that greatly decreases the cleansing ability of the soap again. Sorry about that. I need to turn. Yep, but it will not cause such problem while you talk about it in soapless detergent. So that's why changing from the historical development of having a detergents, we start from soaps actually. Okay, and because you may find fats, oil, and also lye. So it is from potash ash, for example, potash ash, some type of grass in which I burn it into the form an ash, and I try to add water to form a highly alkaline solution. 啲草木灰啊. So it is a very alkaline substances. So it is what we can in the past. While nowadays, because later on you know that it will cause some issues about forming water insoluble substances, which greatly reduce the cleansing ability of the soaps. So here comes a slight modification, right, to turn to soapless detergent. While that new substances would help work well in acid and in hot water. Okay, so do you understand? And with that chemicals, it may cause it will serve you something different about that too. But of course, if you want to talk about that too, one more point that you may know is about the biodegradability. Biodegradability. For soaps, it is more biodegradable. Okay, while for the soapless detergent, it is non-biodegradable. Now, because of the raw materials of making such, you may know it is quite hard, right, for soapless detergent particles to be degraded naturally. Okay, there are no such microorganism that is able to decompose it. But for soaps, the fats and oil, the triglycerides, even though I change it to carboxylate ions, the structure of it is more or less similar to fatty acid. So the fatty acid can be finally be degraded. Okay. Of course, there are something more about the environmental issues about that too. Okay, is the addition of some other chemicals, just like phosphate. Now, something more as a extra materials. So So you may, in order to tackle the problem, somebody would need to deal with hot water by adding phosphate salts, phosphate salts. So in terms of sodium phosphate, it is intended to reduce the hardness of water. But sadly, because phosphate contains phosphorus, so we would increase the chance of red tide. Do you know what? Red tide, it is made up of what? What makes red tide?
嗰啲 algae 嗰啲啊。
Okay, algae bloom. Okay, so we've got algae bloom. But the algae would need some fertilizers. So phosphorus is a very good raw materials to make the algae grow in full speed. So we call it algae bloom. Have you ever heard of that? Algae bloom. So it is a type of red tide. And you know what will happen to the biological issues later on. So this is chemistry, but we would not tell it in detail now. Any questions so far? Any questions? Have you all captured this? Okay. So for the retrieval later on. Now, indeed. Are you ready? Okay. To have the next page. Okay. Now we come to this again. So for the making of the, now as said before, changing from soaps to soapless detergent is our migration to tackle the problem of water insoluble substance. Okay, as said before, SCUM is called a scum. So similarly for magnesium ion and calcium ion, right, that greatly reduces the cleansing ability of the soaps. So that's why we need to have a slight modification, or by finding a quite long carbon chain from petroleum, okay, and then do the process such as to get this. So it's a very long process that you may know, okay? You add a benzene to form benzene sulfonate, right? And consol to form sulfate. Altogether, we call it benzene sulfonate. Okay. So this is what you may know about this. And indeed, nowadays, if you want to talk about the synthetic detergents, it's not just anionic detergents. Okay, what I just said is anionic detergents. Indeed, we have got ionic detergents. So take a look on that. Can you spot for me where is why that served as a detergent from the structure? Take a look on this. Lam Sing Hon, what do you find in this structure?
Got a positive charge.
Yes, positive charge. So how will you what is the significance? What is something good to the cleansing property? What will you call it? Hydro. What? Hydro what? Hydro means water.
Hydrophilic.
Hydrophilic, which means water loving. Okay, it is we call it a hydrophilic head. Because it is of a small size, we just tell it as head. How about this? We've got a very long carbon chain, C18H37. So you count you may find it is a very long carbon chain, CN2N+1. Okay, aliphatic, the strict chain with no CC double bond. Okay, all those are just CC single bond. So what will we call this?
Hydrophobic.
Yes, hydrophobic. While hydrophobic means water hating or the oil loving. Okay, hydrophobic tail. So why you call it tail? Because it's a very long shape. So by doing so, we would know this part, it will dissolve in oil. Okay, how about this? The hydrophilic head, they will help dissolve in water, which serves as a very authentic structure of the detergent particles. Okay, only by having this, you may process two important properties of cleansing. One is wetting. The second one is emulsifying. Do you still remember that two terms? Wetting means I decrease the chance of making the water droplet as a ball. While emulsifying, which means what? You are going to turn the oil and water get mixed together, so to form an emulsion. Okay, similarly, could you please do the same for non-ionic detergents? Please spot for me the hydrophilic head and hydrophobic tail. Where will you find? Where will you find such? Do you find it? How about this structure? Can you do the same? Which is hydrophilic? Which is hydrophobic?梁家傑。
係咪 C15H 嘅
C15H31 is hydrophobic or hydrophilic?
hydrophobic.
Yes, hydrophobic. Hydrophobic. Okay. Why? Because it is just a very long carbon chain. So even though they just shrink it and they just fool you that it's just a very small short chain. No, it's a very long chain. Hydrophobic. Where is hydrophilic? Which part is
the hydroxy group?
Yes, hydroxy group. You may find this one OH, OH, OH. So this part, it is said to be hydrophilic. So do you realize? So again, because I said yes.
ester
Ester. You take a look on this. Will you think that? What do you think about this too? Is also hydrophilic? Is it? Is it?
應該係。
Yeah. Now, if you want to talk about this one, is delta minus a high electronegative atom. We have got lone pair electrons. So would they form hydrogen bond with water?
Should be.
Yeah, but we usually circle OH is because of the formation of more hydrogen bond. Because we have got
more extensive.
O. Yes, we've got just O, but also the H, which is also able to form the hydrogen bond. But for the O here from the ester group, okay, from the O in the ester group, usually it will have that O, right? And it must be that O to form the hydrogen bond with the neighboring hydrogen atom in water. So the chances of having the formation of the hydrogen bond is much less than with what we call it as a hydroxy group here. Okay, because it's not just O, but also the H, which can form hydrogen bond with the neighboring water molecules. Okay, is that clear? So you may get to know, I in one mock exam paper, I have once asked something similar, even though I mark it as non-ionic detergents. People need to confine the area in which we said it is hydrophobic and hydrophilic. Yes, I have tried it before. So please search for me one chemical, okay? Do it on the web now. You have got the computer with you or you have got a mobile phone, please search for me. What is the active ingredient of tea seed powder? Have you ever heard of this term? Tea seed powder. Have you ever heard of that? Our traditional wisdom, okay? What are the chemicals found in the tea seed powder which causes the cleansing ability? Do you know? Very good. Saponin. All of you, please search on the web, saponin. Please search it on web, saponin, and search, and please search for the term saponin, the structure, and circle it for me. Now, what is the where can you find the similar thing? Saponin. Okay, so you may have got this. You may have got this. Very strange chemical, isn't it? So do you find somewhere we will have got a hydrophilic and hydrophobic place? This one. Okay. Where you will say that is hydrophobic, where you will say that is hydrophilic. Very strange, isn't it? I want to know, where is hydrophobic, where is hydrophilic? Where? I want to know, where are you? Is that OH? We've got some OH. What else? Where? Hold on. Where? Where you will find it? As hydrophobic, hydrophilic.
hydrophobic 即係OH 嗰度，然後唔 sorry hydrophilic 係 OH 嗰度，然後 hydrophobic 應該係咪右邊嗰扎
？Where from where to where? I cannot find it. So in order to recognize which is said to be sure for hydrophobic, it is mainly so strange. I would search, I will do this as indeed. Now, this is hydrophobic. So this part, it is hydrophobic. Now I can't find the area, this one. Why? Why is it hydrophobic? Water hating. Why is it water hating? Now, even though I have got H, something is missing. Something is hidden. What is that? All those are just carbon, right? Carbon hydrogen. It's just it do not have process any groups which form hydrogen bond with water. So we will call that hydrophilic or phobic.
Hydrophobic.
Hydrophobic. Okay. How about this? It is on place here, including now let me confine here. Okay. And also here. Okay. Can you get my point? So it seems like having a having a chop in the middle. Okay, so we find that mostly on the left-hand side is being hydrophilic. On the right-hand side, it is hydrophobic. Why is it hydrophilic here? We have got OH group, right? What else? Mainly OH group, right? But also O atom also process. They will have a hydrogen bond formation with water. Can you get my point? So saponin, 茶籽粉, it is is our traditional wisdom. You know that what is the use of 茶籽粉 in the past? People in the past, do you know it? Washing their wash their hair, right? You use it. It's just like a shampoo. You know it. So because of this, but it is it a type of cationic, anionic, or non-ionic detergent? Is it a cationic, anionic, or non-ionic detergents?
應該 non-ionic 咯。
Non-ionic. Why? No charge, right? Can you see that? No charge. No charge. No. Even though I tell the whole part it is hydrophilic part, it's not a hydrophilic head. It's quite a big big part. Okay, in which it is water soluble. Okay, but no charge there. Is that here? Can you see the word 做數? So it is a type of chemical, okay, which help dissolve in oil and water well. But wait a minute, even though I've got the 茶籽粉, okay, TC powder, we need to do one action in order to make it to make the cleansing action possible. How? You need to rub it, okay? You need to rub it. You need to shake it. So remember, every time while you are going to clean substances, remember, first of all, you need to wipe. You need to wipe. You need to wash. You need to rub against the two materials together in order to make the cleansing action happen. What else? What else? No matter what detergent particle you're having. Just like nowadays we have been coming through some cold days these days. So anyone who need to help cleaning the dishes for your parents, that silence 冇啦，唔做暖男啊？李晴啊，
唔識
有冇做暖男啊？
好凍啊，唔暖好凍。
你好凍，即係冇啦。咁你屋企人洗碗洗碟唔覺得凍嘅咩？
唔係我洗，但係我都覺得好凍嘅啫。
咩啊？
冇嘢，即係
冇嘢啦。So how would you ensure that the cleaning of the dishes is effective in winter days? 除咗頭先我講啦，我要洗嘢咧，一定要係捽嘅。仲有第二樣嘢要做啲咩啊？冬天一定會做噶啦，洗碗碟，有啲人一定會開噶。太凍乜啲水會點啊？
用暖水啊？
係用暖水。咁你知唔知道暖水除咗舒服啲之外，what is the other effect on the cleansing property and the cleansing effect? Do you know? 唔知。喂，
你太凍嗰啲油會變固體啊嘛。
係好。第一樣嘢，嗱我落去 please mark it down， 一定會有人問你啲常識嚟㗎。你點拍拖啊，大佬？又係獨留家中啊 ？Number one, hot water. It is better. Why? Because it will make the molecules, they will move more freely. So we are going to make a emulsion more easily. Okay. Second, in order to make the emulsion, what should be done? I need to add what? I need to add water. 一定要支水。 Have you ever tried cleaning the dishes without water？ 有人試過啊？唔會啊嘛，即係譬如啲人係話 ，Wow, you have got the dish, you have got the dishwashing liquid just directly put it here, and you just open the tap and then let it wash. Sorry, no. Okay. If it doesn't happen, you need to rub. Okay. Only by doing so, we can make emulsion. Because the dish is full of oil, I need water. So that's why if you want to wash the dish, usually they will give you a sponge. Okay, why? Why will you usually give you a sponge? It helps.
It has
make what?
friction.
Helps makes what? Foam. While the foam it is just the start of having a emulsion. Okay, by squeezing, rubbing, okay, with that get mixed with detergent, oil, and water more easily, such that they can form foam. While the foam can be easily washed away by water. Don't you know that? Oh, Mr. Chin, you just want to tell me how to wash dishes properly. Yes, that's right. 生活常識小百科係嘛？就係呢啲啦。You need to wash the dishes using hot water. Okay, you rub against the dish with hot water, please. Okay, rubbing better with a sponge. Okay, by doing so, you can wash the dish more thoroughly. Do you know that? You should have experience, right, Mr. Tan? You have got experience of washing dishes for someone, right? So of course you should know what you have to do. Questions? No? Great. 即係我下次再提翻你啦。You go to the, if you still have a chance, right? Go to the chem lab to do experiment. Okay. Never just spray those detergent liquid. Okay. You just open a tap and let it flow. The cleaning effect is nothing. You need to rub. Okay. You need to rub. 知唔知㗎？ You understand? So let's have a recap. Try to let me know if you understand by checking the MC, and I would like to choose one questions or two questions about detergent. Let you know something more about that. Okay. Let's have a discussion on the MC first. I give you some hints because we need to be much recap about the different type of questions. Remember, it's not just MC questions about soap. It also includes some other questions about polymer, aspirin. Let me see. Question 2. Question 2. The structure of the soap is shown below. Which of all statements on soap is correct? Is A. It can decrease the surface tension of water. Okay. We will use this one term to describe the ability of decreasing surface tension of water. What is it called? We use one adjective to describe this. What property are we mentioning?
Wetting.
Yes, wetting. WETTING. So this is the first term I would like to draw attention to. Wetting. Wetting means the ability to wet the surface, but of course it's a type of tautology. If you want to get another meaning without the use of the word wet, it means decrease the surface tension of water. So B is not correct. Okay, B is not correct. So change this. How will you modify this term?
Fat instead of petroleum.
Yes, fats, animal fats, plant oil, right? How about C? How will you modify it, Deng Junhei? Why is it wrong, Deng Junhei?
Not for iron.
What iron?
But is it water?
Water, hydrophilic
Or
part responsible for it. The answer should be within this, because you're talking about structure of soap, right? Water itself is a poor cleansing agent, as said before, because it has a high surface tension. It doesn't form emulsion with water, so it does not get mixed well with oil. We call it immiscible. Anyone who can help? Hydrophilic part?
應該 COO 減嗰邊啊嘛。
Yes, it is. How we call it? We call that carboxylate. Carboxylate. Okay, so it is not a good cleansing function in hot water. Why? It forms something. When you're long, it forms what? Do you know when you're long? Why it doesn't work well in the hot water? Hello, when you're long, are you here?
I'm here.
Hello.
I don't know.
You don't know?
我未 catch up 翻嗰個進度。
Okay, doesn't matter. Start us again.
Hot water contains calcium ions and magnesium ions, so it will precipitate with the soap, and it does not make scum.
Existing and
CO minus and then 2Ca2 plus or RCO minus 2Mg2 plus. It is somewhat water insoluble. We will call it a scum. Because I formed this, we will no longer having an hydrophilic part which dissolve in water, because the whole thing is water insoluble. So it greatly decreases the cleansing action of detergents. So the answer is A. Which of the following two compounds can react together to form a condensation polymer? Suddenly go back to condensation polymer. Okay. Can I have Shanghai? Condensation polymer. A, B, C, D.
Option D. Dot.
Or D. D for dot. Okay. So why you choose D?
Because
now,
both of them.
We have got two types of monomer. First of all, how about the structure?
We have got diamine and a dicarboxylic acid.
Okay, diamine and dicarboxylic acid at both ends. Okay, so remember, it is bifunctional at both ends. So this is our technical term. It's bifunctional. Okay, at both ends. So if you cannot mention this, just tell it has two functional groups at both ends of the molecule. It has two functional groups. So we have got amine and carboxyl group at both ends. By doing so, if you do not understand what is that, I can in my times when I teach CE, okay, third level chemistry, they also get to know about this. So my analogy is that it seems like having a chain. Okay, you know that a chain, a very special type of chain in which we have got two cards. One card we have got the rings, okay, which help connect with a hook. Okay, a ring and hook, ring and hook, ring and hook. So the making of a card will be something like this. Of course, don't argue with me because especially for those people who love MTR or love chain, you talk about the chain, the structure of it should not be that, okay? Because usually the chain, the structure will be this, very mainly of this, right? It's different, So in reality, in chemistry, we also have this type of structure, which will also have condensation polymer. But once I use this, it's just one type of monomer, is okay. I can get the condensation polymer. But you have got that two strange shape. Of course, you need that two types of monomers. Can you get my point? Okay. How about number 4? Sorry, number 4. Ronald, number 4. What do you think? Commonly used to make a drainage pipe.
Maybe I should check what is drainage first.
污水渠
水渠
sewage.
污水渠嗯
淡滾油 A, B, C, D. What is that? First of all, Ron, do you know what are those for? Polymer, which means, okay? Do you know what are those for? A, correct.
前面有個
What is that? The first one is
呢個
PVC
yes, PVC. The second one,
未記
oh, 微幾. Oh, don't worry. We will have a quiz on addition polymer and condensation polymer soon. It's PS. Do you know what's that? Polystyrene. How about C? And how about D? Now we cannot tell the exact name of this, right? So it is PET. Okay, but this one, even though you don't know, don't worry. We collectively call it as a polyester, right? How will you know it? Because the next O, the next connecting atom should be O, right? If you follow the repeating unit, you may guess. So this one is an ester. This one is also ester. Okay, of course, these two, they also form an ester. So it's a type of polyester. So you usually use PVC is because of a more rigid structure. Okay, it's more hard. Okay, a type of plastic, but that type of plastic will be easily melted upon heating. But it's fair enough. If you talk about drainage pipe, you use PVC. And also it's chemically resistant. Okay, when you compare with C and D, we seldom use it because usually drainage, the drainage pipe should be chemically stable to the attack of acid and alkali. Okay, but not for polyester. Remember, polyester can be easily hydrolyzed in acidic and alkaline medium. So C or D is a bad choice. Is that clear? So how about number 5?
It should be D.
Hmm?
The answer should be D.
D.
D for dog.
Yeah, D for dot is polymer chain can be broken in the presence of dilute sodium hydroxide solution. Which part of this structure will be affected? Can be broken. Which part will be broken?
ester.
Ester. You will see ester here. So it is altogether you form another ester. The ester linkage, okay, will be broken upon the action of alkaline by alkaline hydrolysis. Hey, come on! Today we need to you need to have a quiz on chapter 31. Do you still remember? Question 6. Incorrect. Choose the wrong one. Okay. Oh yeah. Do you know what's that? Question 6. Boy, it's the polyamine. It's not correct. So what is the correct answer? We call it
polyamide.
Yeah, polyamide. Can you see that? This is amide, not amine. Polyamide. So if you want to talk about amine, the general structure will be this. it is a terminal amine, or even though you talk about this, is also amine with the LQ group. Okay, or even though I have got this, this is also an amine. Okay, so the difference is on the degree. Okay, this is primary, secondary, tertiary amine. Okay, but it's not amine, it's amine. What is the proper name of this polymer?李澤星, do you know what is that proper name of this polymer?
Nylon 66.
Nylon 66, yes, that's right. Nylon 66, because we have got both amine, the original chemicals, and the acid part. Okay, acid part having 6 carbon, so we call it 66. The first 6 refer to this, okay, the amine, while the second 6 refer to this. Okay, just remember 7. 黃俊熙 Which of the following alcohols is produced when olive oil is heated with concentrated NaOH solution? The stop. Okay, propane 1,2,3 trial. It is a glycerol. Okay, 甘油 is a common name. So it is decomposition of the product of the triglyceride. So remember, triglycerides, we have got a general structure like this. So we talk about this part, okay, being glycerol. So you are going to think, finding out what is that? It's propane 1,2,3 trial. Thank you. Question next, Wang Senghin.
Boy.
Boy. The question X, the answer is boy. What's wrong with B? B is not correct. What is the solid form? What is the solid? It's not glycerol. So what is it?
Got soap.
Oh, so it's a soap. So what is the soap? What is the chemical nature of the soap? It's not just glycerol only. What do we call it? It's a soap, but that soap, it is indeed a mixture of the 2 chemicals. One is sodium carboxylate. The other one is glycerol. So indeed, glycerol also get mixed with the soap particles. So, but glycerol is very important because to you as well, because it will help make a layer, right, of a barrier to prevent the loss of water, right, from your skin. So also is a type of moisturizer. Number 9, do you know it? Glycerol will help retain moisture on the skin. 保濕啊。Number 9. Cosmetic chemistry， 無端端阿 Sir 有講呢啲嘢。黑北魏俊滔 ，Question 9。What will be produced by alkaline hydrolysis of triglycerides? Wei Juntou, are you here? D. Yeah, D, that's right. So this is the sodium carboxylate, while this one it is just glycerol. Okay, the condensed formula of glycerol. Propane 1, 2, 3 trial. Number 10. Polyester, polyamide again. Polyamide again. 好位咯。好位咯。Is B addition polymer, correct? Is it correct? Addition polymer. A is pentane 1,5-diamine. X is this. Okay, yes, that's right. So this is not correct. It's a condensation polymer. How about C? Number 3, the repeating unit of the polymer Z is shown below. What's wrong with it? What's wrong with it? Why is it wrong? 張思維
多咗個 NH 裏面係嘛
Where? Which part?
At the right side.
On the right side, something is more is extra. Where is it?
NH 嗰度多咗。
NH. Okay, it will be one more NH because what's next? You go back to go it as repeating unit, right? Can you get my point? So you are going to split the 8-mide into half. So originally it's 8-mide. 8-mide. So you are going to split that. Okay, you chop it, and you may find on the left-hand side being come from amine, from the right-hand side that may come from the exit. So the you may soon realize that the NH is something more than before. Okay, it's some more repeated, right? So 11. 馮家謙 Which of them can form a stable emulsion when shaken with oil and water vigorously?
1同3B.
Boy, is it correct? Boy. Which stable emulsion? So what is the hidden message? It serves as the function of the detergent. So in order to set a particle showing the detergent property, we need to have wetting and emulsifying. So all those would need the help of the structure. The structure should have 2 parts. One is hydrophilic, one is hydrophobic. You are going to choose again. Hydrophobic, hydrophilic.
係咪有分數到嗰啲啊？係咪 C 啊
？B 啊 ，C， 喂 B 定 C 啊？
但我點解我覺得係 B？
因為你錯咗啦。
唉，算啦，我 follow
點啊 ？It's not that logic. It's not logical. 搞乜嘢啊？Okay, so the answer is C because we have got hydro. This part. 馮家謙 what do you call it? Hydrophilic. While hydrophobic is here. Please mark it. Hydrophobic. Okay, so you need that too. Structure in order to say it is a detergent. Now, one more special point I would like to add is on here, right? So you may get it as a branch chemical. So what as said before, Mr. Chin has said that for the soap particles are usually biodegradable. Sorry, it's not for this case. So with a branched with a branched straight chain, okay, with some branches, they are said to be non-biodegradable. So this is what the people who make the soap should be highly aware of. 12. 12。邊個未答啊？答晒啦嘛？好，林成漢啊驚。12. B for boy. All right, B for boy. So this one cannot form condensation polymer, but they can also form a polymer. They can form addition polymer. So I would like to ask the question again. Why would you say 1 and 3 are able to form condensation polymer? Why? 無限碌啊！問完又問啊，一定要識噏啊。Why will you say that 1 and 3 can form condensation polymer? Tell me something about the structure. Cyrus again. The structure.
I'm sorry, can you ask the question again?
Condensation polymer. Why would you say that 1 and 3? Okay, exactly. Being able to form a condensation polymer. Can you explain in terms of the structure?
In the first chemical, there is an amide group and a carboxyl. No, amine.
On the left hand side,
yeah,
right?
Yeah.
How about this?
And then there's a carboxyl group at the right end.
Okay, so it serves as train like this. Okay, so you have got the ring and then a hook. Okay, so you may connect it as a condensation polymer. Okay, how about number 3? Number 3, any structural features that help you make it as an condensation polymer. 陳學家。
There's a hydroxy group at one end and a carboxyl group at the other end.
Carboxyl group and hydroxy group. Okay, so at both ends, right? But Mr. Chin, for the first one, I understand. It seems like both ends. But how about statement 3? It seems not in the both ends, right? One is at the end, one is in the middle. So how can we draw the structure of the polymer? Can we still draw the structure of polymer having this? Can we? Of course, yes, right? So do you know my second question? Draw me the structure of the polymer. But just show me the repeating unit, okay? Show me the repeating unit of question 1, statement 1 and statement 3 here. Now, before the end of the lecture today, I need that too. Please draw for me the structure, the repeating unit of the condensation polymer formed by 1 and 3. Now, for those who know the answers, you may capture the screen and send it to the WhatsApp group. Okay. I know it will be quite hard to show in the chat box. How about WhatsApp group? WhatsApp group, it seems easier, right, for you to trace the answer. So for those who have drawn at 1 and 3, I need the repeating unit, not polymer, okay? Repeating unit Okay, all of you, please send it here. I need the repeating unit for 1 and 3. 我李晴，I need to give you a copybook. What is that? I cannot recognize your handwriting. Very poor handwriting. So as your appearance. For take a look on Ronald's one, C2H5, CHNH2, and then CHCH3, OHCO. Let me take a look on the others first. CH25, CH, CH3H. Okay. How about the others?呢層你係要做2個，不過咧第一個你都錯啦。搞咩你？喂，李晴再你講。
我睇錯咗佢個問題。
How about the others? HCH3 OK， 唔按一個睇咗啦，跟住下一個。呢個係何偉林學咧，唔睇咗啦。乜嘢啊？你搞咩啊？喂，唔掂喎！李晴，你知唔知你寫乜啊，大佬？咁即係你做乜？搞咩你？喂，其他人可唔可以幫阿李晴睇啊？你知唔知佢寫咩啊？圈住個劈咩㗎？25個 H 啊？咩嚟㗎？
我留個括號啊，
正經寫一次啦，你
係
個個都寫到，你係寫唔到，咁搞錯啊！你阻住人收工，好肚餓啊！我快啲啦！
好，寫。
李健樂，喂，李健樂撞鬼嚟啊！第三嗰個，你睇下你自己錯咩 ？The connectivity of atoms. Take a look. The carbon should be connected to the carbon in the middle. Is it connected to H? Please change it again. 你見咯 The same case for 馬家樂。Okay, please draw it again. Better. But I can hardly recognize your handwriting, 李晴again. I need to buy you a copybook. 個5字都寫唔到。黃奕朗。OK， 好，再誒。黃俊熙。Yes。鄧俊熙。Yes and 林成漢。又係林成漢 number 3。 睇下留意下個 carbon 發生咩事。你睇下馬加樂嗰個馮家謙第一個 N 上邊指住個 bond 嗰個 H 係咩㗎 ？H2 咩㗎？點方㗎喂 ？N single bond H2 喎咩嚟㗎？學校日又係同一個問題喎，大佬你哋呢個啊？好啦，呢度點寫？我係要咁寫嘅，留意住呢個碳同呢個碳係黐住噶嘛，你就唔可以即係個 CH3 個中間夾住啊，個 C 楞住 H 啊，咁都唔啱噶，得唔得？其實一錯嗰啲好多都係呢個問題啊。望多次先，張思懷又係啊，再寫過。梁家傑又係，哇！梁家傑你想點啊你？你望下你個第二嗰個固之然係同一個問題啦。睇下第一嗰個咩嚟㗎？個 N 發生咩事啊？跌咗落嚟嘅，個 N 跌咗落嚟嘅喂，見唔見到啊？見唔見到自己需要啲咩啊？知唔知？應該咁啊嘛。咁啊，得唔得？個 N 唔會跌咗落嚟㗎，冇人知你個幫連去邊啊 ？Yes, better. Okay. Okay. Is that clear? Okay. Which part is difficult to you? Now, I didn't go full review on the questions. Okay, shall we have an overall recap on the long questions in the next lesson? We need to take a look on that because we haven't been trained about the questions about detergents. Okay. 好考嘅condensation polymer 同埋 detergents 所以 for that two topic very important you better read it again and again and try to answer that. Okay, in full. Okay, is that clear? Okay, we just stop it here and let's have a lunch. See you guys. Bye bye.